Welcome, everyone. I'd like to share with you two big lessons that we've learned from taking healthcare-specific large language models and actually applying them in real-world projects. Um, I think you'd be interested because those were two things that surprised me, surprised us, and go a bit against the main kind of marketing messages that you hear from a lot of LLM companies. So I'm also curious to know if this would jive with what you experience, or if I need to learn something from you. So the first lesson we've learned is that really in the vast majority of medical generative AI solutions, you only use the LLM basically as a user interface for the user, and not for its ability to actually have knowledge and answer questions. And to explain what I mean, I want to show some example of projects we have worked on. So this use case is a use case with really one of the biggest payers in the US, and their problem is as follows. There are 50 states in the USA, and there are few additional other territories. For each one, they have more than 100 different plans, and each plan is each insurance plan that tells you what you are entitled to is more than 100 pages long. And each person, when they call customer service and comes, look, I need to do a hip replacement. I want to understand, what's my coverage? Do I need to get a referral? What will be my, copay? What else can you do for me? If you call as a patient, you may be on the Missouri Silver Plan 278X year 2019. And what it means that when the customer service person answers your question, they have to look up exactly the document for that plan. And those documents are long and they're all fine print. When they do this, it often takes the customer service people between 20 and 30 minutes to find an answer, okay, because these are very kind of fine and detailed questions. And the question for us was, look, can you use one of those, chatbot, magica things that you have, so that our support person can just type in the question, you can just tell them, oh, if this is a, dental non-cosmetic procedure, this person has a copay of this, right? And they do not need a referral from their GP. Great. But what was very important are to make sure that when you answer, you only answer from the specific document that applies to that patient. So not from what you generally know, not from the internet, not from similar plans or other documents. Because once you give an answer, even if it's on the phone, those are recorded calls with customer service, they actually are legally binding, right? So you can't tell someone to do something for free and then send them a bill for $10,000, even though you can try. So that was one example of a use case with the pair. With one of the really top five largest pharmaceuticals in the world, we worked on another use case. And then what they wanted to provide a chatbot for patients and their family members to ask questions about their products, right, about their drugs and medical devices, right? So if you get diagnosed with this horrible new disease, they'll tell you, oh, don't worry, this pharmaceutical company, they have this solution for you. You want to come and say, oh, what did I land myself into, right? So, I was just diagnosed with schizophrenia, with seizures, with asthma, with Crohn's disease. What does it mean for my lifestyle? What will be the side effects here? What can I do? What can I not do? What's going to happen? What do I need to know? And the pharma company want to provide answers to people, right? To their parents, to their kids, to the patients themselves. But what's really important here is this. When a patient asks a question, you do not answer from the overall internet what you've learned. You do not answer from Google. You do not answer from Reddit. You don't even answer from PubMed and medical research paper. You only answer from the exact set of documents of patient communication that pharma company legally told your country that it's going to use for patient education. So you cannot have a pharma company telling the regulator that, oh, we're telling these side effects to every patient, but actually in the chatbot give a different list. So what was very important to them is that whenever you answer a question, there's only a specific set of documents that you can use for this patient, only a specific set of versions, and thou shall only answer from these documents. So in a sense, what really similar to the pair use case, that in the sense you don't use the LLM knowledge or memory, you use a certain set of documents that were provided. And we've seen the same thing for probably the most common and use case, which is for medical providers, so doctors, nurses, who want to ask about their own patients. So I have my own set of patients that I treat, right? It could be a hospital, it could be a clinic, it could be something in between. And I want you to summarize the information about the patient. And for example, I want to ask, look, give me all the diabetic patients. Give me all the patients who have had a heart attack in the last 6 months and have not started taking the beta blocker. Give me all the patients who've had a cardio issue identified in their latest radiology report, and we have not followed up with them to start treating it yet. So to do that, what we need is first of all, we have the thing that where we need to connect kind of the timeline view of that patient, right? So we have some structured data, some unstructured data, some PDF, some documents. We need to build that whole knowledge graph about the patient. But then, of course, what's really important is that when I ask you about the patient, you need to only look at my own patients. You need to look at only the current data that I gave you, and you need to give me a correct response, right? So just like the other use cases, you need to use my own private data. You need to use very specific data that only I approve, and it's actually important that you show no creativity, right? Which is something LLMs are amazing in, but it's just not required for this use case. So what we see in all of these cases is that people do want the chatbot experience. And what we all the time is, look, if you can make this work, this is much better than what we have now. So if people can do chat and can just ask a question in natural language and get a response, they don't want to use BI tools, they don't want to use reports or dashboards or drag and drop interfaces or search. They definitely don't want to use SQL or regular expression or anything of the sort. People really like the chatbot experience. By the way, the way you know this is because the way most business people actually use those tools today is they just send an email to a team of BI analysts or data analysts that gives them the answer, right? So they come and say, oh, if I want, all the revenue from, new subscribers for the last quarter, they just send an email and ask, please tell me what the number is, right? They don't actually go into, BI tools or use SQL or use search to do that. And they just want to come say, look, instead of having this whole team of people who do that, can the chatbot just do it for me, right? Faster, automatically at a lower cost. So people love the experience, but at least in healthcare, what we see very consistently is that they do not want to use the chatbot knowledge. Okay, and actually a common requirement is never answer from memory. So if I ask the LLM, what's the capital of France? Okay, and you cannot find in the document store the exact document that's the right version that tells you what the answer is, the only correct answer is I don't know. And please, not only do not hallucinate, do not tell me even if you think you know. And what people want, and you can see kind of here some of the UI that we have built in our own kind of chatbot platform. People want to load their own knowledge bases, right? So come say, oh, I want to use PubMed, or I want to use clinical trials. Do I want to use a bioarchive, right? It's not, peer reviewed, yes or no. Do I want to load my own documents and my SQL databases? So I want to choose between them. I want to be able to update them at scale and in real time. But that's the only information that you use. And by far, this is the most common use case we see. The other very important thing that we're seeing is the need to explain and discuss answers. And this is more than a nice to have kind of responsible AI feature where, yes, show me explanation. This is because medical questions are almost never one and done. So medical questions are never what is the capital of France, where there is one answer. Very often, for example, if I ask, show me all the diabetic patients, the next question you're going to, okay, well, why do you think this person is a diabetic? Someone could be a diabetic because they have an ICD-10 diagnosis code, or they could be a diabetic because they have 2 abnormal H1C test results in the last 6 months. Or maybe they're a diabetic because, look, I can see that they're on this, they've been on metformin for the past 2 years, right? They're taking this drug. Maybe they're diabetic because they told me they're diabetic, right? And that's all I know. So the point is there are many different definitions, and they fit different use cases. So very often a doctor will ask a question, they can say, wait, what do you mean high blood pressure? What do you mean the late stage cancer? What is late stage for you? I don't think this person apply. And you need to be able to explain the definitions. Similarly, if you're looking at medical evidence, right? And the question is, oh, go and ask PubMed, what are the non-side effects for aspirin? The next question you're going to get is like, where is this list coming from? Right? Is this from the clinical trial where you just you just listed everything that came out? Is this a list from peer-reviewed papers? Is this a list from meta reviews? How recent are they? How many patients were involved, right, in this study? Is this a study on humans, right, or even is it on animals? So very often doctors will want to look at your explanation and come say, let's talk about this patient, let's talk about this document. And we see this with our own medical doctors. This is a fundamental part of the user interface. So what this means from an architecture and solution design perspective, it means that, first of all, almost all the solutions we see are kind of RAG LLM solutions, so retrieval augmented generation, where what the LLM does is it's the front end, and yes, you ask a question to your chatbot, and you ask it in natural language, but it does not actually answer the question. What it does is it formulates a query. That query goes to a vector database, right, or some kind of semantic search database. It retrieves relevant information, and then it formulates it, right? So instead of giving me a list of 5 or 10 results, it formulates it, it summarizes it, it gives me nice bullet points. But in that sense, really, the LLM is only a user interface, right? It's who I ask the question, and when it gets the result of the query, it shows me the results in a nice human readable way. What it does not do, it does not actually answer, which begs the question: is like, do I really need a 100 billion LLM if it does not actually need to memorize all of medical research, all of the internet? The second architectural implication we're seeing is that we have not seen use cases where you actually need to tune your LLM, right? Because, for example, if you look at the example of the insurance company, I do not need to tune the LLM with all of the insurance plans for all of the US, because first of all, they're extremely similar to one another. But more importantly, when I get a specific question, you do not answer for memory. You do not need to kind of memorize that specific document within the LLM. In sense, you shouldn't, because you may get the wrong one because they're very, very similar. It may be out of date, and I don't want to keep retuning every week. What you need to do is just please go find the correct document, find the right paragraph there, and answer. And the third architecture implication we're seeing, as I mentioned, is the document as context, where within the conversation, someone says, okay, now I want to talk about this research paper, this clinical trial, and then that is your context, and you ask questions about that. And that also seems to be a fundamental part of the workflow. So those are kind of the solutions we are seeing, and that's really how we're seeing our own chatbot platform evolving to solve. That's one thing. The second thing we have learned, which I'd like to share with you and get your feedback on, is the following. Current GPT model suck at the classic task of information extraction. And people still use them for that, but really what we see is that really for the most common task of actually looking at a clinical note, at the biomedical research, clinical trial, and extracting patient information, trial result characteristics, GPT models can do it, but they're really not good at it. And here are some examples. So look, at Johnson Labs, what we do is we provide natural language processing capabilities to the healthcare and life science industries. And we've seen quite a lot of use cases there. And the main thing we promise to the industry is that we will provide you state-of-the-art accuracy. So whenever something, a new library, a new model, a new paper, claim to have better accuracy in a task, we test it. If it reproduces, if it generalizes, we tune it for healthcare, and we give you that model. So a lot of what we do is this kind of benchmarking, right? And as you can imagine, this year we've done a lot of benchmarking with LLMs to see, so that when they are better, definitely we'll use an LLM to do it, and we'll move to that. And if you are customers, you'll just get it out of the box. So in 2022, last year, we've published a set of peer-reviewed papers, and we showed that we have achieved new state-of-the-art accuracy on tasks like relation extraction, mining adverse events, de-identification, right, in different languages, clinical and biomedical name entity recognition. So we feel strongly that we know where the state of the art is, right? We know where the benchmarks are, and we are the most accurate in quite a few of them. And a lot of the question we get this year is, okay, this is all nice, but like, did you finish moving everything to use an LLM yet? And our answer is often no, but not because we haven't finished. We actually have healthcare-specific LLMs, as we've seen, and they are excellent for some tasks like question answering, conversation, summarization, but they're just not as good as what we already have on the classic information extraction task. And here's one example. This example looks at the task of extracting social determinants of health, which are basically aspects of your healthcare that are not classic medical diagnosis, but impact you, how long you will live and how well you will live. So, for example, do you have a home or are you homeless? Do you have health insurance? Are you in a stable relationship? Can you afford healthcare? Do you eat enough every day? Do you have social support and so on? And one of the interesting tasks that you do on medical notes is to be able to extract social determinants of health and normalize them and so forth. And one benchmark we've recently run in the past few weeks was to compare our current state-of-the-art models that were built by data scientists, medical doctors, using different types of transformer, deep learning, transfer learning methods, to a set of GPT-4 prompts that also went through a whole process of prompt engineering and optimization. And what we found is that really GPT-4 still makes about 3 times more mistakes than our current state-of-the-art social determinants of health models. And we see it across a whole number of variables, and there was a whole number of prompts involved. But what's nice is, yes, you can ask it very quickly, just here's a story. Is this person homeless or do you have housing insecurity? And just tells you. But the point is, it's not actually very good at doing that. And you have models that are far smaller, far simpler, that are more accurate. This is not the only case. When we look at kind of the classic clinical name entity recognition, so being able to look at a clinical note and extract diagnoses, symptoms, procedures, drugs, tumor characteristic, chemotherapy cycle counts by genomic biomarkers, demographic patterns. We see similar things. We have a benchmark, and by the way, you can see the URL below. These benchmarks are public. The notebooks are public. The code is public. The data is public. Please reproduce it. If you get different results, please tell us. But what we have seen fairly consistently is that the current models we have make about half of the errors that ChatGPT does. We see an even bigger gap when we look at the task of not just extracting entities, but mapping them to standard code. So if you're looking to map entities to the most relevant SNOMED code, UMLS codes, ICD-10-CM code, NDC codes, RxNorm codes, LOINC codes, and so on. So here we've published the benchmark resolving entities to the most relevant ICD-10-CM codes. And we see that the gap is significant, also to the point of being usable for some use cases versus almost not usable for the majority of all use cases. And we compare it versus both the GPT 3.5 and GPT-4. De-identification is another example where, yes, you can do de-identification with GPT models, but when you compare to the current state-of-the-art models, really what we see in the ChatGPT makes more than 5 times more mistakes. And the thing with de-identification is it's pretty binary. Either you're at 98, 99% accuracy, which means you're doing better than humans and you can automatically de-identify, or you're at the point where you're just not that accurate. For example, let's say you're only 92% accurate, which means that whatever it is that you do, a human still has to look at each and every document, right, before you can actually use it. Right, so being kind of good or almost good is really next to useless in the de-identification use case, because really it's binary. It's either a human has to look at each and every one, or a human does not. And right now, de-identification is a task where, with the current state-of-the-art model, a human does not need to look at this. And we've done it several times at scale, and it works very well. The other thing to note is that it's not, even if you come and say, look, accuracy is okay, I'm okay with 70, 80% of the accuracy, because for whatever reason, it's a model I prefer to use. The other problem is that LLMs are also much more expensive to scale. And for de-identification, currently one of our biggest case studies is with Providence Health. They have used the software publicly, went with case studies, showing, talking about how they de-identify more than 700 million patient notes. But also they were very concerned because of the scale with the compute costs of what would it take to do this, and they've done a lot of optimizations. And at the end, between the compute costs and this kind of software license code to get the identification models, they assume that they were at about 1,500 notes per dollars, right? So for $1, you can de-identify about 1,500 patient notes, and they've actually tried the same with GPT-4, and there's at least one paper that talks about, oh, here's DID GPT and here's the end-to-end pipeline. And one of the problem is that then what you get is, instead of 1,500 notes per dollar, you get about 15 notes per dollar on the current pricing, and that is the public pricing. And the thing with the de-identification is, if you're dealing with PHI, you cannot use the public pricing. You actually have to use the much higher pricing for kind of secure enterprise environment. But even with the public pricing, it's really to the orders of magnitude in terms of cost, which really means that it's not designed for this kind of use case at scale. So for a while, we thought that maybe we were the only crazy ones, but now there are more and more academic papers that basically show the same results. Here's one paper that compared name entity recognition, relation extraction, and kind of some negation detection, compared GPT models versus, this is PubMedBERT. PubMedBERT is an embeddings model, it's a transformer model that's been around for 3 years. It's definitely not state of the art anymore, far from it. It's still been used in some research capacity. But they showed that even versus kind of this older model, PubMedBERT significantly outperformed both kind of GPT models they looked at, so 3.5 and 4, in name entity recognition, relation extraction, multi-level classification tasks. And we are seeing more and more papers come out with the same results. That not only are these models much smaller, much cheaper, much faster, there's a significant gap in accuracy. So to summarize, really, I mean, two things that we are finding, and fairly consistently in kind of real-world use cases. One is that in most medical generative AI solutions, really the LLM is only used as user interface, which means that a lot of things that people claim you should do around tuning, around scaling, around updating the models, we still don't see the value in. The second is that current GPT models are poor at information extraction. So people still use them for classification, for entity recognition, for question answering, and they do work, and it's nice that you have kind of the nice zero-shot experience. They're just not very good at it, especially compared to the other models that are already out of the box, off the shelf, available to us right now. As a result, what we are seeing is that current real-world system really just integrate multiple techniques, right? So maybe you do information extraction in the backend, you feed it to a vector database, use the LLM to have kind of the nice natural language question and answer and conversation in context. And I think really those are early days, and we expect to see this evolving. With that, if your experience shows you other things, please tell us, please educate us. I'm very curious to see where we'd be, a year from now, with those kind of things, and how things would evolve. With that, thank you very much.